Hello, this is video number 66. And last time we looked at an example of merge sort, but that's not why we're here. We already had a sorting algorithm. We're here because we are doing theoretical stuff and algorithm analysis. So let's look at merge sorts. Worst case. Now let me see if I can make a case for that, so to speak. What about the best case? Well, we could do the best case, but you know what? That would take more time, and also it's not terribly interesting. Bubble sort's best case is when the list is already in order, but you know what? If your list is already in order, who needs the sorting algorithm? We don't really care what it does when there's no work to do. We care what does it do when there's maximum work to do. How bad can it possibly get? So a lot of algorithm analysis is actually analyzing the worst case scenario. There, I hope I've convinced you. What is the worst case? What is it? Answer? Well, you might think, well, every sorting algorithm's worst case. It's got to be when the list is completely backwards. It's actually not always, strangely. And this one's a little trickier to come up with. I'm going to do this per iteration, which means per level of splitness. That is not a technical term at all. But I'll do the example and then point back at this and say that's what I was talking about. E-T-R-A-T-I-O-N. An iteration is when we look at the whole list at least one time. Almost all of the left half gets merged. I'll put that in quotes, not sure why. But the urge hit me, so I put it in quotes. Almost all of the left half gets merged, and then the last left element, good grief, this is a ridiculous description. The last left element is larger than any of the right. You know what? I'm having regrets right now. I should have done the example first and then come back and written this description, because this description is just impenetrable, is it not? Almost all of the left half gets merged into the bigger tray. And then, oh no, we get stuck. We hit a snag. The last element on the left turns out to be larger than any of the right. Here's what I'm talking about. For example, let's say we've got a list like this. 5, 12, 13, yada, 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 42, minding our own business, 45, 5,000. Oh no. Trouble a-brewing. That's our left-hand side. That's our left half, all sorted by merge sort. Now these halves are not going to be drawn to scale because I didn't leave enough room on the board. But over here, let's say that this starts off at 65, 67, 71, dot, dot, dot. And the last two elements on this side might be 350 and 372. There, that's it. Now, by the magic of our recursive algorithm merge sort, by the time we get to the level of these two halves being merged into the grand finale big long list, we get to assume, remember, that all of the left is in order among itself. All of the right is in order among itself. So all we got to do is merge these two pieces together. Like a zipper, the metaphor I'm wearing out here. 5 is less than 65. Sure it is. 12 is less than 65. 13 is less than 65. Yada, yada, yada is less than 65. 42 is less than 65. This one hasn't budged. 42 is less than 65. 45 is less than 65. Bonk. 5,000. 5,000 is not less than 65. So we almost made it to the end of the left half, and everything just pretty much got copied down without thinking about it. Even though every single one of these got compared to the 65. Every one of these beat the socks off 65, and that's why they're already in the big tray at the bottom. But now we ran into 5,000, and look, now all of a sudden the right-hand team starts catching up. 65 is less than 5,000. 67 is as well. 71 is as well, 350 is less than 5,000. 372 is less than 5,000. The very end, the very last 5,000. See what happened there? I'm going to pause this video and perhaps stop it. It looks like I might be filming things backwards. You suppose that's possible?